Assalamualaikum and hi everyone. In this video, I'm going to explain the first subtopic for chapter 1, which is 1.1 dimensions of physical quantities. So we look at the first learning outcome, 1.1a, which is define dimension. So whenever we are going to study about a topic in the chapter, we always refer to the learning outcome. So learning outcome ni akan ada di setiap subtopic. So I already include in your notes the learning outcome. So kita always refer kepada learning outcome so that it's easier for us. Dia macam sebagai guidelines untuk kita to study what are exactly the things that we need to know in this subtopic. Okay, so basically dekat subtopic 1.1, first thing we need to know is how to define dimension. Okay, so dimension ni, based on definition, it is a technique or method used to describe a physical quantity in terms of its basic quantity, regardless of the system of units used. Okay, dalam kata yang paling senang, macam ni. Okay, for example, kita ada a few units here. Kita ada sentimeter, 1 sentimeter, 1 meter, okay, 2 miles, 3 light years. So all of this, kita tengokkan dekat sini, we have different unit. But actually, all of these different unit actually have or use the same dimension. Dia gunakan dimension yang sama, iaitu dimension of length. Semua ni adalah untuk kita ukur length sebenarnya. Okay, walaupun dia berbeza unit, tapi dimension dia adalah length. So this is what we call as dimension. Okay, quantity. Okay, quantity physical based on basic quantity. Okay, untuk lebih senang kita tengok di table here. Okay, so table dekat sini, kita tengok in terms of basic quantity dia adalah length. So basic quantity length, kita tahu length ni kita boleh gunakan sentimeter, meter, what else, kilometer. So all of this we are using, okay, we are using the basic unit length. So basic unit length ni, apabila kita translate dia kepada dimension, kita gunakan dimension L. Must be capital letter of L. Okay, next one we have the quantity for time. So untuk time we can use different unit. We have second, we can have millisecond, we can have hour, okay, we can have minutes. But all of these are actually, okay, basic quantity dia still time. So time dimension dia adalah T, capital letter of T. Okay, next one we have mass. Okay, mass can be in kilogram, can be in gram, okay, can be in pound. So mass ni, dia punya unit can be what I have just explained, kg, pound. Okay, ni adalah unit yang kita gunakan lah, bukan SI. SI unit is this one. So SI unit we always refer to this one, but these are all the units that we can use for this quantity, basic quantity. Okay, so for mass, kita tahu dia adalah can be in terms of different units, but actually it's still the mass. So kita translate dia kepada dimension M, mass. So benda ni semua adalah different units, but actually same basic quantity. So that is what we call as dimension. And dimension we always write as this one, capital letter of L, T for time, M for mass, for current, either I or air. For temperature, it is the theta, the symbol theta. For the amount of substance, it's the symbol of N. Okay? Okay, so in physics, we always use dimensional analysis. Okay? We always use dimensional analysis to determine the unit of the physical quantity, or to derive mathematical expression, or to check the correctness of physical equation by using the principle of homogeneity. Okay, so basically dalam kata simple dia, dimension ni adalah translate daripada unit. So if the unit is meter, dimension adalah length. If the unit is centimeter, dimension adalah length. Okay, so now kita tengok the example here, which is we come to the second learning outcome actually, to determine the dimension of the derived quantities. So tengok example 1. So dekat sini we already have the solution for velocity and acceleration. Okay, so let me go through this solution here. Okay, kita tahu velocity. Okay, velocity dia punya unit adalah meter per second kan? Okay, meter per second. So meter ni, okay, meter dia punya dimension adalah length, which means it is L. And then per second, dimension dia adalah time. Dan dia adalah per, which is exponent negative 1. Okay, sorry, bukan exponent, which is to the power of negative 1. So LT to the power of negative 1. So basically kita translate saja daripada SI unit kepada dimension. Benda yang sangat simple. Okay, kamu tidak perlu buat benda ni pun tidak apa. In the end, just daripada meter per second terus translate kepada dimension. So kita dapat the final dimension is here. Okay, sama juga macam acceleration. Okay, as long as you know the SI unit, then it's easier for you to just derive the quantities. Okay, so basically here, SI unit untuk meter per second, untuk acceleration adalah meter per second square. So meter dekat sini adalah length, per second square adalah time per second square. Okay, so this one is for you to easier to understand how to directly translate. Okay, but for this question, sebab dia minta we want to derive the quantity. So kalau derive quantity, then you have to do all of these steps. Kalau derive quantity, you need to do all of these steps because we know that velocity dia ada dia punya formula sendiri, di mana dia adalah change of displacement divided by the time interval. Okay, so kita tengok the first one. So we already have velocity and acceleration. So now kita tengok momentum. Okay, so momentum, linear momentum. Okay, first of all, okay, we need to know what is the formula for momentum. Okay, this one you need to, kamu kena tahulah formula ni. Kalau tidak tahu, then kamu tidak boleh lah cari dimension dia. So you need to know the formula for momentum. Okay, so formula for momentum, usually momentum kita letak dalam simbol P. So formula for momentum is equal to mass times with velocity. So we always start with the formula and then mesti letak dalam bracket. Lepas tu barulah kita translate mass. Okay, translate directly lah. Mass dia punya dimension adalah m, and then times with dimension for velocity. So for velocity, okay, you can directly use this one here. Okay, sebab kita sudah buat dekat soalan A, then we can just use this one. But kalau kita tidak buat di soalan yang sebelumnya, so meaning that you have to start with this. Okay, so now sebab kita sudah buat, so you just write down LT to the power of negative 1. So it is equal to M LT to the power of negative 1, di mana unit SI unit for momentum is kg, mass adalah kg kan, and then L is velocity punya As a unit, you just masukkan kg meter per second. So that is for momentum. Then next one, we need to look at the density. Okay, density. The formula for density. Okay, this one kena hafal lah. I'll just give it to you straightforward. Formula dia adalah sama dengan mass divided by volume. Okay, so mass directly dia, direct dia punya dimension is just m, and then volume ni adalah from the dimension of length actually. Okay, dia benda yang sama. So if we have area kan, so area basically is length times with length, which means we have L times with L, which is L square. So dia benda yang sama. Volume ni adalah isi padu kan. So we know that the volume, the SI unit for volume adalah meter cube. So dimension dia adalah length cube. So it is equal to ml exponent ml to the power of negative 3. So SI unit is kg per meter cube. Okay, so last one is the force. Okay, so force, which is we use the symbol F. Force, the formula is equal to mass times with acceleration. So again, mass is just m. Acceleration, we have done this here. So just ambil L KL per T square. So equal to ml per T square, di mana SI unit, kalau kita directly translate from here, it is kg meter per second square. Okay, ataupun kita boleh gunakan force ni, selalunya kita akan gunakan in terms of Newton, so N. Okay, so that's all for example 1.